Today we're going to be going over earthquake early warning technology, which can save lives, prevent injury, reduce disruption to critical activities, and protect resources. Seismic switches and control and monitoring software can be used to implement automated actions like alerting drivers approaching bridges that could collapse, open doors that are normally closed to allow people to get to safety, stop elevators that could break and snap during a strong earthquake, turn on audible warning alarms and lights, close gas valves, open firehouse doors, alert school children to take cover, and alert doctors to stop delicate procedures seconds before shaking begins. EEW systems are operating in several countries. I'm Maria Limoni, sales manager here at ICP-DAS USA. I've been with the company about 9 years, and I've previously held positions of web developer, application engineer, and technical sales engineer. I also have Robert Morau, one of our technical support engineers, with me to help answer questions. And he has 12 years experience in the industrial automation industry. Later, he'll be showing a demonstration with SCADA software and seismic switches. ICP-DAS started in 1993. Our headquarters is located in Hsinchu, Taiwan. We have over 100 R&D engineers and help them with developing new products, adding features to products, and also to support our customers. We provide free technical support, and we can also provide programming services and systems integration services as needed. We're currently looking for a programmer to work at our office in Lomita, California, near San Pedro and Torrance in the South Bay. They need to have experience with C language, Visual Basic, C#, C++. If you know anyone or if you're interested, please let us know. Earthquakes are releases of energy in the Earth's crust, which create seismic waves. Earthquakes are caused by sliding along earthquake faults. Earthquakes are measured with seismometers, which provide information through vibration signals. Seismic scales calculate the severity of earthquakes, which are described by magnitude and intensity. Shaking by earthquakes is expressed as a percentage of G, where G is the acceleration of a falling object due to gravity. Seismic waves may be a result of earthquakes, explosions, or volcanic activity. Earthquakes happen suddenly and sometimes cause destruction, including fires, road and bridge damage, and collapsed buildings. Early earthquake warning technology helps prevent further damage, saves lives, shuts down critical systems as needed, and can help to alert personnel about seismic activity. An earthquake early warning system consists of accelerometers, communication equipment, computers, controllers, and alarms that can provide real-time notification about strong earthquakes that have potential for damage. Seismic switches are used to acquire seismic activity through MEMS accelerometers, which measure the force of acceleration. Seismic switches can be used to alert drivers on a bridge about bridge destruction so people will know a bridge is unsafe to cross through programmable controllers and web-based LED displays. They can also help train operators to stop a train in case of seismic danger. They can also be used to stop elevators, shut off gas valves, start generators, stop plane landings and takeoffs at airports, and to notify fire stations about earthquake activity. Some big earthquakes in the U.S. include the 7.9 earthquake and tsunami in Hawaii. Took 123 lives and caused a landslide that knocked most wooden houses off of their foundations. The 7.8 in San Francisco on April 18, 1906 caused a lot of fires and took 3,000 lives and caused $524 million in property loss. The 6.4 in Long Beach on March 10, 1933 resulted in many collapsed buildings and houses due to lack of earthquake-resistant architecture. A 9.2 Alaska earthquake and tsunami on March 27, 1964 took 253 lives and caused $311 million in property damages. The 5.9 north of Whittier was centered in Los Angeles County and San Gabriel Valley. It was felt as far as San Diego, San Luis Obispo, and Las Vegas in Nevada. Communication and power was temporarily lost. Many workers were stranded in disabled elevators. There were also water and gas main breaks and collapsed ceilings in buildings. There was a 7.3 near Landers in Southern California near Palm Springs that caused buckled roads and collapsed buildings. 3 hours later, a 6.3 earthquake hit Big Bear. These quakes opened a 44-mile-long rupture in the earth. This map here shows some of the highest hazard areas in the U.S. based on horizontal type shaking. The central states have less danger from destructive earthquakes. The western United States, Alaska, and Hawaii would receive the most benefit from early earthquake warning systems. EEW technology is being used in high-speed railway warning systems. Seismic data is gathered from seismic switches and passed over Modbus RTU to cellular device servers like GT540 3GWA, which pass the earthquake data over the cellular network back to control centers. SMS text messages are sent out to mobile phones based on configurable magnitude data. If there are any earthquakes over 4.0, text messages are sent out to personnel. SCADA software runs on a PC in the control center and collects and displays seismic data information. Based on the information from the seismic switches, the train will slow down or stop as necessary. EEW technology is also used in building earthquake warning systems. Data collected from other EEW equipment and seismic switches located in buildings provide information to the local system to close valves, turn on fans, lights, to stop elevators as necessary based on seismic events. The data is collected and stored in a database on a shared server. The seismic switches are located on different floors in buildings and are networked together over Ethernet cabling over a local area network. EEW technology is used in factories to alert employees and to control critical and dangerous equipment as necessary. Information from seismic switches is passed back over 2.4 GHz wireless radio frequency networks. The SST2450 RS485 serial-based RF modems communicate up to 300 meters or 984 feet and pass the seismic data information back to programmable controllers that have a database for logging events. Doors that are normally closed are opened to allow employees to get to a safe area during or after an earthquake event. EEW technology allows seismic data around and on bridges to be collected and passed back over cellular networks through G4500 3G cellular-based C-language programmable controllers. Web-based LED displays located at the entryway to the bridges warn drivers that it is unsafe to drive on the bridge. Information about seismic activity is passed to nearby locations in the EEW network. Real-time earthquake notification and feeds are available from usgs.gov. You can sign up to receive email notifications of any earthquake above 6.0. They also tweet alerts for earthquakes worldwide above 5.5 in magnitude on Twitter at USGSTED and at USGSBigQuakes. The Red Cross offers text message alerts if you text Get Quake to 90999, or you can download their free Android or iPhone app that will give you alerts. Other earthquake apps are available from private companies and providers that are free or cost a small fee. Robert is now going to show you a demonstration on EEW technology, including programmable automation controllers and SCADA control and monitoring software.
Okay, hello. My name is Robert Morale. I'll be showing Indusoft Web Studio, but this demo actually shows you some of the features which you can use with the SAR sensor. Let's see, since the SAR sensor produces Modbus data, you can make a communication connection to Indusoft software using the Modbus RTU driver or the Modbus TCP driver. Let's see, this demo actually has several industry examples where it shows off the graphic ability and ability to create reports, show different features. Let's see, we have a wind energy demo. This would be symbolic of what you could do with the earthquake sensor. So imagine at each location you had an earthquake detection sensor, and when an alarm was triggered at one location, you would be able to have early warning at other locations throughout a map. This one is a wind energy demo, but you can incorporate maps saying for like railway applications and power applications in which an earthquake could cause harm or could cause damage. And it would be actually beneficial for you to be able to, say, slow down a train when it's coming around a corner if an earthquake was detected, because you don't want a train to be able to go full speed, and then they can safely make it out of the tunnel, and all the passengers will be able to be safely evacuated from the train. Let's see, we have a few other demos. We have a wastewater demo. This one shows some alarm features, which you can use at the bottom using the alarm window. You can show an earthquake has occurred at a different location and switch production to a different facility. You can also monitor through the Ethernet the connection for the earthquake and be able to detect that production will be slow at a different location, and again incorporate higher production capacity at a different location, specifically for the fuel industry, fuel and gas, and the oil industry and energy production, as well as for building automation. With building automation, you can know the status of the earthquake alarm using the Modbus RTU protocol and be able to switch generators on, turn on evacuation alarms, create reports which show the status of, say, gas monitoring systems, and be able to control, say, elevator features through the SCADA software. For some other features, here's some features. Using all these graphical symbols like bar graph, color, text and data, where you can show an alarm, like say, flash a message, earthquake or fire has been detected. With visibility, you can turn things on and off so that you can visually see, like say for instance, a siren showing that the alarm has been triggered in a certain location, and be able to investigate that to determine if there's a fire or if an evacuation is required. Let's see, using position and resizing, you can graphically display the value of the earthquake alarms and any other alarms, as well as monitor your elevators and other building facilities like lights, HVAC, and irrigation. Does anyone have any questions? See, I'll go through some of the other images. Here's some of the other objects which are available using InduSoft. Let's see, with trend curves, you can graphically and visually show the status of, say, energy consumption using power meters. And if you actually created a trend graph, you can actually see the seismic activity waves from the SAR module. The alarms would be a main feature which you want to incorporate with this, so that you can verify that the building has been evacuated, or if there's fires caused by earthquake or any other situations where people might need to be rescued or saved. And the multi-touch. Does anyone have any questions?
There's no questions.
Okay, we thank you for attending this webinar on earthquake monitoring systems. If anyone has any questions or applications they want to discuss with us, please feel free to contact us. And Maria Limone is our sales manager, and I'm Robert in our tech support department. Thank you for attending.
Thank you.